Hi all, my name is Prafful and today we are going to look at if someone asks you what are the OOPS concepts and can you please elaborate them. So we are going to look at what is meant by OOPS. Now what is meant by OOPS? OOPS means object oriented programming language. Okay, object oriented programming language. Now what is mean by object oriented programming language? Like to be a object oriented or OOPS language, that particular language need to have the four features. We call it as major pillars of the OOPS. Okay, and those major pillars are first one is most important, that is polymorphism. Second is encapsulation. Now next is abstraction, and final one is inheritance. So these are the four major pillars. There are minor pillars as well, so we will firstly look at the major pillars. Okay, now what is meant by encapsulation? Encapsulation means we will be binding the data and logic together under one unit. Now how do we achieve it? If we want to achieve it, we need to use the class for it. Okay, to achieve the encapsulation. Now what is the purpose of encapsulation? To protect the data. In our code, data is the most important part. Logic can be built again, but if your data has gone, you will not be able to recover. Like you are using WhatsApp, Facebook, you do have your accounts on WhatsApp, on the Facebook, also you do have accounts, bank accounts, right? And you do have the data, like you do have the bank account number, your account balance, right? And all the data which is like when you have debited, you have credited the cash in your account. So these all are the data, and it is important to protect the data. So that's why they came up with the encapsulation. Now you will ask, now how do we achieve the protection? How we are achieving the protection in it? Like there are few mechanisms. Whenever you are defining the data and the logic inside a class, you have to use those keywords and those features of the Java or C++ programming language. In that way you can protect the data by using those all features. Okay, so to implement the encapsulation, we have to use the class and the features which are provided by the language. So in that way you can achieve the encapsulation. Now let us look at what is meant by abstraction. Now if we compare the abstraction in the real world, you see lot of examples. Like if you are driving a car, in the car we do have a gearbox, right? So for every car, like every brand's car, the gearbox will be the different, like internally the implementation of it will be the different, but the way of having to gear it will be same, right? So the interface which they have provided is same, but internal implementation is different and it's very complex, right? So and that is not needed to show to the customer or user, right? So they hide it under one cover and something. Or if you want to see the coffee machine, right? If you in a company or in the college, and if you want to have the machine, like if you want to have the coffee through the machine, then you will click the button and whatever type of coffee you want, you will get out of it. But internally what that machine is doing, you don't know, right? But they just provided you the interface and you are using that. So in programming also, you don't need to show everything to the user or whoever is using your code. So we hide few things, we abstract few things, right? So that is we call the abstraction. We can use that by using private keyword, or you have to manage your code in such a way that you don't need to show everything from your code to the user, whoever is using your code. In that way we can achieve the encapsulation. Now if we see another example like projector, right? In the projector what we have, the focus is on one screen and there it emits the light and you can see the data whatever coming out of that projector, right? It will project the pictures or video whatever is coming out of the screen, but you don't know what is the implementation inside that box, right? So everything has been wrapped around with the plastic or whatever material it is having, so you don't need to see the internal implementation, right? So they are abstracting the data whatever present inside that. So in that way we can achieve the abstraction. Now let us look at the next concept, that is inheritance. Now in inheritance, if we took a normal example, like the word is itself saying that we inherit something. Like in the parent-child relationship, the child inherits the properties of the parent, right? Like whatever the features parents are having, like the color, their language, they learn it absolutely. But in DNA also they get few things from them, right? So they are inheriting the properties from the parents. Now let's take an example. Consider we are having a class A and class B, and class B is inheriting the class A. Now class B is inheriting class A, means class A is base class or parent class and B is a child class. Now here there is a relationship present in the inheritance. Now how it is? Like if we take this example, here you can see that vehicle is a parent class, okay, and car, truck and bike are the child classes who has inherited the properties of vehicle. Now every car is a vehicle, every truck is a vehicle, every bike is a vehicle, correct? And for every vehicle you need number of tires and engine. For particular car or truck, the number of tires attribute value will be changed. Like for number of tires, if you say for car you need 4, for truck you need might be 6, might be 8, for your bike you need two tires, right? And engine implementation will be different of the engine, but yes, these parameters will be needed, right? So these classes are inheriting the properties of the parent class vehicle. So car is a vehicle, truck is a vehicle, bike is a vehicle. So there is a relationship has been maintained in the inheritance, right? So that is how the inheritance been worked. Now let us look at the next point, that is polymorphism. Now in polymorphism, if we see like a real-time example, consider you are at the signal, right? And at the signal, now this is road, consider, okay, few bikes are coming from this side, few bikes are coming from this side, few coming from this side, few coming from this side. So there is, here is the signal. Now people who are coming from this side, they need a green signal to go to the next. People who are at this side, they also need green signals from this side, and people who are at this side, they need to have the red. They should not cross the road while these people are having the green signals, right? So the signal is same, it is acting on its way, but people who are standing at this side or this side or this side are acting different, right? So what is meant by polymorphism? Poly means many, morphism means forms. Like the same functionality is behaving in a different way or providing the different output as per the situation. So that is why we call it as polymorphism. Poly means many, morphism means forms. We can achieve the polymorphism by using the two things, static loading and dynamic loading. In static loading we use the method overloading, and in dynamic loading we use the method overriding. In this way we can achieve the polymorphism. Now these were the four major pillars in the inheritance which we have gone through. If you like, the next point will be our minor pillars. We will cover that into the next video. If you do have any points me to cover, then please do comment and please subscribe to my channel. Thank you for watching me.